Hello, I'm Nancy Diaz and I'm going to present to you my second video for my physics class. In this video, I'm going to present to you two problems. The first problem is about how many stairs do I need to walk in order to burn the calories from a sneaker. I'm going to solve this problem using the first law of thermodynamics. The second problem is about an inelastic collision between a wooden block and a bullet. In this problem, I'm going to find the final velocity of the wooden block after the collision, the heat produced by the impact, the change in temperature of the bullet after the collision, and the final acceleration of the wooden block. In this problem, I'm going to need to use conservation of energy and conservation of momentum. The first problem is about to find how many stairs do I need to walk in order to burn the calories from a sneaker. The first thing I have to do before I start to do any problem is to list the values. I have a mass of 120 kilograms. The sneaker has 250 kilocalories and the length of one stair is 0.18 meters. After listing all my values, I'm going to find the correct equation to solve this problem. This problem involves the first law of thermodynamics, which states that internal energy is equal to heat minus work. Since this is an isolated system, internal energy will be equal to 0, and our formula will end up as heat equal to work, which can be simplified by heat equal to mass times gravity times height. Since we are trying to find how many stairs do we need to walk in order to burn all the calories from a sneaker, we're going to work out the equation to solve for height, and we will end up with height equal to heat divided by mass times gravity. I'm going to put in my values and my equation will look like this. Height equal to heat, which is 250 kilocalories. But do not forget to convert those kilocalories to joules. To find the joules in the sneaker, you are going to multiply 250 kilocalories times 1000, which are the calories in 1 kilocalorie. Then after that, you're going to multiply the result. In my case, is 250,000 times 4,186 joules, which are the joules in 1 calorie. And my result will be 1,046,500,000 joules. So the value for height will be 1,046,500,000 joules divided by 120 kilograms times 9.8 meters over seconds squared, which is the value for gravity. I'm going to use my calculator to find the answer, and my answer will be 889,881 meters. This is the answer in meters. But how many stairs? To find the stairs, I'm going to divide the height by the length of one stair, which in my case will be 889,881 meters, divided by 0.18 meters, and my result will be 4,943,783 stairs. For my second problem, I'm going to present an inelastic collision between a wooden block and a bullet. The first result I'm required to find is the final speed of the wooden block after the collision. To solve this problem, I'm going to use conservation of momentum. But first, I'm going to list all my values. The mass of the bullet is 0.010 kilograms. The mass of the wooden block is 3 kilograms. The initial velocity of the bullet is 100 meters per second, and the initial velocity of the block is 0. The next thing is to write the formula for conservation of momentum, which states that the total momentum of two objects before the collision is equal to the momentum of the two objects after the collision, where P initial is equal to P final. In this case, the equation for conservation of momentum is mass times initial velocity of the bullet plus the mass times the initial velocity of the block equal to the sum of the mass of the bullet and the block times the final velocity. Since I'm trying to find out final velocity, I'm going to set up my formula as final velocity equal to mass times the initial velocity of the bullet plus the mass times the initial velocity of the wooden block, divided by the mass of the block plus the mass of the bullet. I'm going to put in my values into my equation. That will be final velocity equal to 0.010 kilograms times 100 meters per second plus 3.0 kilograms times 0 meters per second divided by 3.010 kilograms, which is the total sum of the mass of the wooden block and the bullet. To find the results, I'm going to use my calculator. The result for the final velocity will be 0.33 meters per second. The law of conservation of energy states that the energy cannot be created nor destroyed, it just transformed, which can be defined by the formula energy initial is equal to energy final. For this problem, I'm going to use conservation of energy. My equation will be initial potential energy plus initial kinetic energy plus initial thermal energy equal to final potential energy plus final kinetic energy plus final thermal energy. I'm going to eliminate final and initial potential energy because I don't have height, as well as initial thermal energy because I don't have heat before the collision. My equation will end up as initial kinetic energy equal to final kinetic energy plus final thermal energy. But since I'm trying to find out final thermal energy, my equation will be initial kinetic energy minus final kinetic energy equal to heat. That can be interpreted by 1/2 times mass times velocity of the bullet square minus 1/2 times the mass of the bullet plus the mass of the wooden block times final velocity square equal to final thermal energy. I'm going to put in my values into my equation, and it will be 1/2 times 0.010 kilograms, which is the mass of the bullet, times 100 meters per second square, which is the velocity of the bullet, minus 1/2 times the total mass of the wooden block plus the bullet, which is 3.010 kilograms, multiplied by 0.33 meters per second square, which will be the final velocity. To find the answer, I'm going to use my calculator, and in this case the result will be 49.84 joules, which will be the heat produced by the collision. The third question is about finding the change in temperature that the bullet raised after the collision. The first step is to measure values. The mass of the bullet will be 0.010 kilograms. The specific heat of the bullet will be 128 joules over kilograms Celsius, and the heat will be the result from our previous question, which is 49.84 joules. For this problem, I'm going to use the formula for heat, which is heat equal to mass times the specific heat times the change in temperature. Because I'm solving for change in temperature, my equation will be change in temperature equal to heat divided by the mass of the bullet times the specific heat. I'm going to put in my values, and my equation will look like this. Change in temperature equal to 49.84 joules, which is the value for heat, divided by 0.010 kilograms, which is the mass of the bullet, times the specific heat of it, which is 128 joules over kilogram Celsius. I use my calculator to find the answer, and the result is 38.9 Celsius has changed in temperature. For my last question, I'm going to suppose that the table where the wooden block is placed has a coefficient of kinetic friction of 0.2 mu. For this question, I'm required to find the acceleration of the wooden block after the impact. The values I have is the coefficient of kinetic friction equal to 0.2 mu. The total mass of the bullet and the wooden block will be 3.010 kilograms. For this problem, I'm going to use Newton's second law that states that the force is equal to mass times acceleration. In this problem, the only force that we have is friction, which is equal to mu times normal force. So our equation in order to solve this problem will be net force equal to friction. Simplified as mass times acceleration equal to mu times mass times gravity. Because we need to solve for acceleration, our equation will be acceleration equal to mu times mass times gravity over mass. Since we have mass in the denominator and the denominator, the masses will cancel, and our equation will be acceleration equal to mu times gravity. For this question, I'm just going to multiply 0.2 mu times 9.8 meters per second squared, and my value for acceleration will be 1.96 meters per second.